Welcome everybody, and what we're going to be looking at today is looking at histograms in statistics. So again, a histogram is something we would have studied when we were studying different types of representing data at Junior Cert, and it's one we're going to go into a bit more detail now for Leaving Cert. So histograms are like bar charts, but they're usually used to represent categorical or group data. Generally it's used, guys, to represent a grouped frequency table like we see in example 1 here. Histograms are generally used to use a group frequency table. There are no gaps between the bars to represent the continuous data. Each bar must also be the same width. So in example 1 here, it says the frequency table below shows the time taken by 32 students to solve a problem, between 0 and 60 seconds. Draw a histogram to represent this data. So I'm going to move over here now to my other board so we can still see the table. It's the easiest way to draw a histogram is to use a square grid like this. Now you should be using a ruler to draw this. This program itself doesn't actually allow me to use a ruler, so I'm going to have as best a straight line as I can here, guys. So what I'd see here is I'm drawing a straight line down, which I should be using a ruler for, and I'm drawing a straight line across to get my x and my y axis. Okay, let's pretend they're straight. Okay, now I know I'm going to try and go from 0 to 60 because we always put the intervals on our y-axis, or on our x-axis. So I'm going to label those now here. So I'm going to have 0 goes to 10, goes to 20, goes to 30, goes to 40, goes to 50, and goes to 60. And as you can see, there's an equal space between each of my intervals. Then I can see that the number of students goes up as far as 12. So I'm going to label each one going up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And my y-axis. And it's very important to label each axis. So we know that the x-axis is measuring the time and it's measuring it in seconds. The y-axis is measuring the number of students. So I haven't represented a single piece of data yet, guys. I'm just constructing my diagram. At this point I'm going to change the colour because it's nice to use different colours for this one, and I'm going to go with green. So we have between 0 and 10 seconds there was 1 student. So I'm going to draw across and down, leaving no gaps between my first bar and the y-axis. Then I'm going to change my colour again and go for the second one here, which is between 10 and 20 there's 2 students. So we're just going to draw another bar like this, again the exact same width, leaving no gaps. Going again for my third interval, which is between 20 and 30, and there's 8 students. So this time we're going up as far as 8, go across, go down. Again, should be using a ruler for all of this to make it as nice and neat as possible. Colouring in the bars to make them distinguishable. Then we're going to go for our fourth interval here, which is between 30 and 40, that there's 12 students. So we're going up again, across. Again, each bar is the same width. It is crucial that each bar is the same width, that we're using a ruler throughout to have straight lines. Okay, between 40 and 50, we're back down to 6 students. 6 students here. So we're going to go to 6, go across, go down, and shade it in. And between 50 and 60, guys, we're only going to have 3 students. The last bar I'm going to draw here is only going to have 3 students. Just like this. And now I have my histogram with no gaps, equal width bars, and labelled axes. Okay? Now, the next one asks me for part 2 to write down the modal class. Well, the modal class is another fancy way of saying the word mode. And the mode we know is the one that occurs the most. So the one that occurs the most would be the tallest bar in our histogram, which I can see is between 30 to 40 seconds. So my modal class would be between 30 and 40 seconds. Then it says, in which interval does the median lie? Well, we know our formula for the median is a half by n plus 1, where n is the total number of pieces of data, which I know in this case is 32. So I have a half of 32 plus 1, which gives me a half of 33. And a half of 33 we know is 16.5. So we know is going to be between the 16th and the 17th student. So now we're going to look here, and I can see that in the first one we have 1 student. By the second one we have 2 students, so 1 plus 2 is 3. The third one we have 8 students, so 8 plus 3 is 11. Which means in the fourth one where we have 12 students, this is where my 16th and my 17th student would have to lie. Which means therefore the median interval would again be between 30 to 40 seconds. Okay, so my median interval again is between 30 to 40 seconds. And that's how we find the median and the modal class of a histogram. Now remember guys, if we wanted to find the mean, I know it doesn't say it in this question, but let's add it in here. If I wanted to find the mean, we would use the mid-interval values. So we know between 0 and 10, the mid-interval value would be 5. So we have 5 by 1. Then we're going to have our mid-interval value of 15, 25, 35, 45, and 55. And we're going to use those mid-interval values to help us find our mean. So 15 by 2 plus 25 times 8 plus 35 times 12 plus 45 times 6 and plus 55 times 3, all over the total number of people, which was 32. So we're going to put that into our calculator now. We have 5 times 1 plus 15 times 2 plus 25 times 8 plus 35 times 12 plus 45 times 6 plus 55 times 3, which gives me 1090 divided by 32, which gives me a mean of 34.0625 seconds, which again we can see would fall between the 30 to 40 second interval. Now, so that's how we find the mean, the median and mode using a histogram. That's how we represent a histogram accurately. Now we need to move on to looking at the different types of skews on a histogram, or distributions. So if we look here now, we have this in our notes. The data in a histogram can be described by a type of distribution, which is indicated by the shape of the histogram. The one that's going to become the most important going forward is the normal distribution, or as we may have called it before in class, the bell curve. Like in the histogram we did above, a symmetrical or normal distribution is the most common distribution in statistics, where it forms a similar bell curve like you see here, where the median and the mode all lies in the center. An example of this would be the heights and weights of adults. Okay? A positive skew is when all the data is left of the center, which generally means that the mode is less than the median, which is less than the mean, and the mode would probably be the most accurate. This, for example, could be the children in a family. A negative skew is when the data skews to the right of the center, where again we have the mode is greater than the median this time, which is greater than the mean. Okay, and this, for example, could be the heights of basketball players in a basketball team. We also have a uniform distribution, which is when all data is spread across the distribution and there is no modal class, as you can see in the diagram here. And we also have a bimodal distribution, where there's more than one modal class. There's more than one section that occurs the most. And a distribution with 3 or more modal classes is referred to as multimodal. Now guys, these 5 key terms are actually in our notes, so take some time, go through them, read over them, understand them, and then we're going to practice constructing our own histograms. Okay? Thanks very much for logging in today guys, and see you later.